So first of all, we'll start with knowing what exactly this differential amplifier is. So basically, it is a device which amplifies the difference in voltage of two input signals at inverting and non-inverting terminals. Or in other words, or in simplified manner if I call it, then we can say it as it is a device that amplifies the difference of two input signals. So you need to remember only this thing, that it will amplify the difference of two input signals. And based on the input provided to the differential amplifier, we can classify it into three categories. And the circuit of that you can see on the display. In one amplifier, we are giving signal to the inverting terminal and we are keeping non-inverting terminal to the zero voltage level. In another circuit, we are giving signal to the non-inverting terminal and we are keeping the inverting terminal at zero voltage. And in third case, we are giving two different signals on both the inverting and non-inverting terminal. So here in this video, we are going to explore all of these three circuits and understand how it works. But first of all, we'll understand about circuit arrangement, equation, and together we'll develop the circuit of differential amplifier. And then after, we'll understand the operation of differential amplifier. So now let's begin with the circuit making. So first of all, we'll take all the necessary components on canvas. For that, you need to press Ctrl plus W and that will open component selection window. From here, I will take all the important components. So we have got all the important components and now we are going to arrange the circuit as per the requirement. So here we have three possible circuits and we had started with the first possible combination in which we are giving input signal to the non-inverting terminal and we are keeping the inverting terminal at 0. This is basically a feedback resistance and this is the R1 input resistance. So this non-inverting terminal we had grounded over here. So we are giving 0 volt signal to this non-inverting terminal and we are giving some input to this inverting terminal. Hey, can you just turn on the white thumbs up button just below this video into a black color? Just try it once and if you can do it, I'll really appreciate your act. And now I'm appreciating your act. Thanks for giving me thumbs up. So now this is the point from where we are going to get the output. And if I want to write the equation of output for this circuit, then I can write it in this manner. So this is the equation of output voltage that we get at this point. And this is nothing but the multiplying factor. And V1 is the input. So here V1 is our input. The combination of these two resistance gives us this multiplying factor. And this is the output that we are getting at this point. Now keep this thing as it is and let me show you the second type of circuit. So now I'm going to prepare the circuit where now in second type of circuit we are giving our signal to the inverting terminal and we are keeping this non-inverting terminal at 0 volt. And now let's check what will be the output voltage in the second case. So this is the equation of output voltage in case number 2. Where we are having this V2 as our input signal and this section is the gain of this differential amplifier, and this is because of this combination of this R1 and R2 resistance. And yeah, one more thing I would like to tell you, that till now we have seen this one simulation circuit and the another simulation circuit. In this video I am going to run all the simulation and I will explain you what will be the effect of changing each of the parameter on the output side and how actually inverting and non-inverting differential amplifier works. So this is the equation of output voltage of second type of differential amplifier where we are giving our input to the inverting terminal and 0 voltage to non-inverting terminal. And now we are going to explore the third type of differential amplifier where we are providing input to the both terminal inverting and non-inverting. So first of all, let's prepare the circuit for that. So here our circuit is ready, and now let's analyze the circuit and then we'll understand the working of it. But before moving ahead, I would like to tell you that if you want to download this and other similar simulation based on Multisim, then stay connected to this video. Later part in this video, I'll tell you how to download this ready-made simulation for your use. So now let's move ahead. Now here on both the terminals we have given the input signals, and in that case if we want to get the output voltage equation, that will get in this manner: the output because of signal number 1 and the output because of signal number 2. So if we combine both the previous equation in this, we'll get so this is the equation of output. But here you can see that the gain provided to both the signal is not the same. In case number 1, the gain is this, which is given to this signal, and in case number 2, the gain is this, which is given to this signal. So when the gain is different to the input signal, we will not have the true sense differential amplifier. So in order to get a true sense differential amplifier, we must have the same gain for both the input signals. And to achieve that thing, the output equation should be modified. We must adjust gain in such a manner that it will be equal for both the input signal. And to change the gain, what we need to do? We need to modify something here in the circuit. So now let's understand what I am doing to adjust the gain. If you want to have a common gain like K and V1 minus V2, the difference of two input multiplied by this gain, and that is what we want to have in output. So to have this thing, we should have a common gain in V1 and V2. So to have a common gain, observe over here, we have a term R2 by R1, right? So in one equation, we are ready-made available this term. So what we'll do, we'll try to modify the gain of other signal and adjust it equal to this. And that is why we are taking this K is equal to R2 by R1. So now we are clear that what we want to achieve, we want to achieve this gain R2 by R1 in this input, right? So we need to modify something over here. But before doing that, I would like to ask, if you have not did it yet, do it now. Just turn the white thumbs up button below this video into a black color. If you can do that thing, I will appreciate your act. And in advance, I am saying you thank you for the act. So let me remove all these things and let's see how to achieve this thing. So over here we have already this much of gain, 1 plus R2 by R1, and what we want at that place, we want R2 by R1. So if we rearrange this equation, then we can write it as R1 plus R2 by R1, and what we want R1 by R2. This is what we want over here, right? This is what our requirement is. So in order to make this gain equal to this, we need to add something in this equation. So what we are going to add? We are going to add a multiplying factor R2 divided by R1 plus R2, and if we are able to achieve this thing, then this R1 plus R2, this R1 plus R2 will get cancelled out and we'll get R2 by R1 of multiplying factor or a gain. So how to achieve this R2 by R1 plus R2 of gain? It is very simple. We need to prepare a voltage dividing circuit like this, where we have R1 resistance, R2 resistance, and at this point we are checking our output. So the equation of this output over here will be equal to like R2 by R1 plus R2 multiply by, for example, this is the input voltage, so multiply by V in. So if we can implement this type of voltage dividing circuit over here, then we can have this gain. So now I am adding these two resistance in this circuit. So here our voltage dividing circuit is ready. This R3 resistance is actually R1 resistance, and this R4 resistance is actually our R2 resistance. So if we arrange everything in this manner, our gain for this signal will shift to R2 by R1 into V1. And now if we place this VO1 over here, then what we will get? So in this case, our output will be equal to the difference of two input voltage multiplying by this gain R2 by R1. And now let's see the simulation of all this 1, 2 and 3 circuit. So first we'll start with this. So to observe both the input and output, we'll have a 4-channel oscilloscope. So the circuit is ready. Over here you just observe our R2 and R1. They both are same, right? So our gain K, the equation of gain is R2 by R1, and they both are 1K. So our multiplying factor will be 1. So instead of this 1, what we'll do, we'll make changes in this R2 and we'll increase gain from 1 to 2. We'll make it 2K. The same way we'll make it 2K2. And now let's run the circuit. So here you will able to see only one signal. The only one signal is visible. It is just because of both the input signal are of same magnitude. Let me change the scale and then you will be able to see both the signal. So the green waveform is actually the input to the negative terminal and the red waveform is actually input to the positive terminal. So let me make both the scales same. So there is no difference in input, right? What was the equation? Equation was V output is equal to K times V1 minus V2, right? Or V2 minus V1. So our gain is 2, but this difference is 0. So that is why we are getting 0 volt in output over here. Now here, let me modify a few changes and then we'll see what happens when we provide two different voltage level of input to this differential amplifier. So here we are giving 3 volt to the positive terminal and 5 volt to the negative terminal. So what will happen when we give 3 volt and 5 volt over here, the difference will be of 2 volt and the multiplying factor will be of 2. So we will get almost 4 volts of output. So now let's run the circuit and observe the output. So this is the output. Over here, this blue waveform shows the output. But one important thing you need to understand that when the voltage at negative terminal is higher than the voltage at positive terminal, the output that we get will be inverting output because higher voltage we are giving to the inverting terminal, and that is why we are getting inverted signal in output. So we have calculated that our output voltage should be almost equal to 4 volts. So over here we'll drag this mark to here. The peak of inverting signal is almost 3 volt. The peak of non-inverting signal is almost 5 volt. So the difference of 3 volt and 5 volt is 2 volt. And when there is a difference of 2 volt and 2 volts of multiplying factor, the output we are going to get should be equal to 4 volt. So at this point, the output is almost 3.971. So we can call it as almost 4 volt. But the output is minus because the higher voltage we are providing to the inverting terminal, and that is why we are getting the output as inverted. Now instead of this, what I'll do, I'll make change over here. I'll make this as 5 and this as 2. So the input at inverting terminal is at 5 volt and input at non-inverting terminal is 2 volts. So the difference is 3 volt, multiplying factor is 2. So the output will be almost equal to 6 volts. So now let's run the circuit and observe what is the output. So from this waveform, you can clearly observe that when the input at non-inverting terminal is higher than the input at inverting terminal, the output will be non-inverting type. And let me show you the magnitude of output. Let me bring it over here. The magnitude of output is almost 5.947, so it is almost 6 volt. That is what we have calculated. So the output is 6 volt, and that is what you can see over here and over here. But now observe over here that the positive voltage and the negative voltage we are providing to this op amp is plus 12 volt and minus 12 volt. So what will happen when our output voltage will be larger than the positive and negative voltage? So let me show you that example. So in this case, our voltage to positive is 9 volt and voltage to negative is 2 volt. The difference is 7, multiplying factor is 2, so the output will be 14, which is greater than 12. So what will happen to output? Let me show you what will happen to output. Let's run the circuit and see, this is the output, right? So whenever this output crosses positive 12 volt, it will get saturated, and the same thing happens whenever it crosses negative 12 volt, it will get saturated. So simply we can say, if the output is larger than the positive and negative saturated voltage, then during that period output will be saturated. So this is how the differential amplifier will work. One important assignment I am giving to you, that you need to observe that what will happen when instead of sine wave I'll give triangular wave to input. One of the example I am showing it to you right now, right? So this is what happens when your one signal is sinusoidal and the another signal is triangular, right? So this is how a blue color of output you will get. So what you need to do, you need to make changes in input signal. Once you use triangular, then you use square wave, and observe what type of output you are getting. And once you understood that result, write that thing in comments below, or else you can communicate with me on my Telegram channel Learning Vibes. If you have any doubt on this topic, you can write that doubt in this comment section below, or you can contact me on my Telegram channel or on Instagram page. Now let's close it. And here we have two other circuits. But right now in this video, I'm not going to cover these two circuits because the length of the video has become so huge, right? So if you want to observe the output of both these circuits, then write in comments below that we want to observe the output of both inverting and non-inverting differential amplifier. So I'll make a separate video on that, and there we'll discuss on the output of both these amplifiers. So if you want to learn that thing, do not forget to write in comment section below. And till now, if you have enjoyed this video, then give a like, give thumbs up, and if you want to learn similar stuff, then subscribe to this channel. And in upcoming video, I'll explain how to use this differential amplifier for practical applications like temperature sensing, and that is really important thing to learn. So if you are interested in that video, then write in comment section about making that video. And once I'll get handful of comments, like 30-40 comments on making of that video, I'll definitely make that video in detail for all of you. So thanks for watching this video, and if you have not subscribed to this channel, do not forget to subscribe this channel. So until we meet again in our next video, till the time, bye bye.